Hello learners, welcome back to the course on construction methodology. In this lecture, we'll try to understand a bit more about the column reinforcement. We'll try to see some complicated columns and we'll try to understand how the reinforcement is given. Then we'll also try to see some certain lateral ties, how it looks practically. And then we'll try to see what are the clauses that are given in IS code books, and based on this, we are going to use the lateral ties and the links. So we'll quickly get into that. So we'll try to understand this. It's not a column, it's a pedestal. We'll try to understand that. Now the difference between the column and the pedestal, we'll try to understand in some other lecture. Try to concentrate on this. Again, it's written main reinforcement. You have to provide 20 diameter bar of 26 numbers. And also, you need to provide 16 diameter bar of 12 numbers. And what is the grade of a concrete that you have to use? You have to make use of a grade of a concrete of M20. That is, M stand for mix and 30 is a characteristic compressive strength of that particular concrete. And the size of this pedestal is 950 by 1250. So this is how it looks. Again, we'll try to understand this. We need to understand one thing. Sometimes what happens, sometimes the structural engineer tries to increase the grade of the concrete, especially in case of column. Let us say in the footing and in the slab and in the beam, you're using a grade of concrete, let us say M25. When it comes to the column, we'll try to increase the grade. Instead of M25, we'll try to give M30 grade in the column. Usually this is done because we know that column is a compression member, and we also know that concrete is strong in compression. Since concrete is strong in compression and column is a compression member, usually what we try to do is, just in case if the steel reinforcement and the size is not matching according to our requirement, we try to increase the grade of the concrete. So usually, I mean, it's not mandatory. Sometimes what happens is you can see two grades of concrete being used. One is for the footing, for the beam and the first slab, let us say you're using M25, whereas for the column we'll try to use M30 grade of concrete. So the logic behind this is, since column is a compression member and we know that concrete is strong in compression, that is the reason we are going to use M30 grade in column. Again, it depends. It's up to the structural engineer what kind of grade he has to specify, right? Fine. So we'll try to understand this. Again, it's written you have to provide 20 diameter bar of 26 number and you have to provide 16 diameter bar of 12 number. Now it's written A here, right? The A in the letter A signifies that wherever the A letter is mentioned, there you need to provide 16 diameter bar of 12 number. We'll try to count that. So it's A here, it's A written here. I mean, this is the bar. This is another A written here. This is another A written here. That means you need to provide 16 diameter bar here, here and here. Again, A mentioned here, another A is mentioned here. So again, you need to provide 16 diameter bar here, another 16 diameter bar here. There is another A here, there's an A here, there's an A here, and there's an A here, there's an A here. So wherever the A is mentioned, only in that portion we need to provide 16 diameter bar. And other than that, from here, like 1, 2, 3, and this is fourth one. From here, whatever number of bars that you get, that is 26, that you have to provide 20 diameter bar of 26 number. So all these are those bars where you need to provide 20 diameter bar. And these are the lateral ties. Now you can see how many lateral ties are. That is also mentioned here. That is one set of 9 stirrups. That means all this compromises of 9 lateral ties. Then one set. If you want, we can try to count it. This is one. This is second. And this is not. I mean, this is a link. This is one. This is yellow is the second one. This blue is the third one. This dark blue is the fourth one. This green is the fifth one. This red is the sixth one. This is the seventh one. This is the eighth one. And this one link is the ninth one. So this is how we are going to provide. So this is how the lateral ties are provided. The long one, this one will connect this, and all these columns. I mean all this reinforcement bar. So this is how a bar is given. We'll try to see one more drawing again. So this is another drawing. Same thing. Again, grade of concrete that you have to use is M30 here. In this case, this is a bit interesting. So what has happened here? You need to provide 25 diameter bar 4 number. Along with that, you need to provide 20 diameter bar of 28 numbers. Along with that, you need to provide 16 diameter bar of 5 numbers. So the letter A and B represents where exactly this 25 diameter bar and where exactly this 16 diameter bar has to be provided. Now with this understanding, now I know that 25 diameter of 4 number of bar has to be provided. One here, second one is here, third one is here, and the fourth one is here. That is why A signifies that diameter of the bar. and the 16 diameter is represented by B. So you need to provide 5 bar. That is why 1, 2, 3, 4 and 5 bar is shown here. And whereas the remaining portion, wherever you are going to provide the bar, those will be 20 diameter bar. All those will be 20 diameter bar. So this is how we are going to provide. And the same way, these are the lateral ties. Again, they are how many numbers? Again, you have to provide one set of 8 stirrups, or this is stirrups. That is why you have to count it. So there are 8 in number. This is a bigger one. Next is this one. Next is this one. This one. All these are 8 in number. So this diameter, I mean, what should the spacing between them? You have to provide a 8 mm lateral ties, and the spacing between each lateral tie should be 150 cm to center spacing, 150 cm to center spacing, 150 cm to center spacing. Right, so we'll try to say one more. So again, this is understood. You need to provide 20 diameter, you need to provide a 20 diameter bar of 28 numbers, and you have to provide 16 diameter bar of 9 in number, and the letter A signifies where you have to provide that. Again, you have to provide 10 stirrups here, so 10 stirrups is shown here. Again, the same thing continues here. Again, you have to provide 25 diameter bar or 28 numbers, and you need to provide 8 mm lateral ties. The center to center spacing is 150. You have to provide 9 lateral ties. One set contains of 9 lateral ties. So this is one more. Again, it's the same thing again. So this is a big, this is another one. This is a bit, interesting. Again, what you have to do is, this is the outer ring. This is the outer ring. Then you have to provide a triangular ring. You have to provide a triangular ring here. Then these are the, lateral ties. These are the lateral ties. And this is a one hook. This is a second hook. It's given. It's the inner links. And this is the outer link. So the one which is bigger in size, we call that as master ring. This is a master ring because it's connecting from here to all these columns. So that is called as master link. And after that, whatever you can see here, all these are this is a triangular link, and this is one two leg stirrups. This is a 2-leg stirrup, and this is one link, and this is one link. So this link has to be, this bend will be usually 180 degrees. This will be 180 degree. So this is how we try to understand it. All these are the main reinforcement. This is all a longitudinal bar. You're seeing it from the top. That is the reason we are going to see this. This how it's this how we are able to identify it. So usually what happens is, when we work for any of the project, this is how those things are given. See, up to the plinth level, you will be given this drawing. And from the plinth to terrace, again, this is your column. So let us say up to plinth level, I need to use the size of the column as 300 by 300. The grade to be used is M25. And the diameter of the bar should be, you need to use 16 diameter bar of 8 numbers. That is why you can see 1, 2, 3, 4, 5, 6, 7, 8. So all these are 16 diameter bar of 18 numbers. And how many stirrups you have to provide? You have to make use of 2. One is that this thing, this is called as master ring, right? And another one is this one, which is a rectangular in shape, not exactly rectangular. Yeah, quadrilateral. So this is how you have to use this. This will be connected from here to here, here to here, here to here. This is how we are going to provide. The same thing continues here. Up to the plinth is over. From plinth to the terrace, again, it's the same dimension of the column will go. Same number of bar will go to the terrace level also. Again, this is how the lateral ties looks. Same thing is seen here. Look at this. So here you need to provide a 300 mm by 400 mm column. You have to make use of M25 grade. Again, you have to provide 16 diameter 8 bars, and you have to provide 12 diameter 2 bar. And the letter A represents where exactly you need to provide that 12 diameter bar. So he's telling that they made a mistake, I guess. Yeah, they have shown 2 here, but here they have mentioned 3A. I think there's a small mistake here. So that's fine, not an issue. How many bars? 1, 2, 3, 4, 4, 4, 8, 9, 10, yeah, 11 bar. Okay, this should have been 3 here. This should have been 3 here. Yeah, this should have been, no, actually this bar is not, then they've done a mistake here. Usually when we see in column, you cannot give even, you cannot give odd number of bars. It should be even, right? 8 plus 2 will be 10. So this is not there. Forget about this. So there is only one, this and this. You need to provide 2 bar of 12 diameter here, here and here. And this the remaining bar are 16 diameter of 8 number. And so this is up to the plinth level. From the plinth to the terrace, again, we need to provide only 16 diameter of 8 bar. So there is no point in providing 12 diameter 2 bar in the terrace portion. And this is a grade of a concrete that you have to use. This is the dimension of the column, and this is how you have to provide. Yeah, so this is how it looks practically, right? If you can observe it carefully, this is a master ring which has gone all the way. From here it has started. This is one ring, and after that there is one more ring which is connecting the inner column, and then there is one more ring which is connecting this way. So this is how it looks practically. Yeah, again, if you can observe it, there's one ring which goes all which connects all the rebar the longitudinal rebar. Then there is one more lateral ties which is connected in this point, right? This is one thing which goes completely. Then there is and one more which is going to connect only the middle 4 bars, right? So same thing. So everywhere, and this spacing what they have mentioned is, let us see, you have to provide 150 center to center, 150 center to center, 150 center to center. Based on the drawing, we are going to provide this. So we'll try to see this again. There's one more bar. Let us say 1, 2, 3, 4, 5, 6. There's eight longitudinal bar. So this one lateral tie will connect all the bar. This is the main bar. We call this as master ring. The another lateral tie is connected to the inner 4 reinforcement bar. So this is connected to 1, 2, 3, and 4. And this the outer one that is called as master ring that is connected here. So this is how it is. Yeah, I'm sorry for that. Actually, the thing is, forget about that. This I will start with a fresh understanding of this. Actually, what has happened? This bar is connected from here to here, right? This column, this column. I mean, this rebar, this rebar, this rebar, and this rebar is connected with this lateral tie. Again, this is connected with this lateral tie. So this is how it is. Okay, forget about the first what I explained. So this is the right way. What has happened? This and this column is connected with this lateral tie. You can see it here, right? It has started from here, it has gone all the way here. From here it has turned. So that is the one. The second is provided from here to the last one, right? Now you can observe it clearly. This has gone all the way like this, right? So this is how it is provided. So as we saw in the previous slides, this is a triangular stirrup that were provided, right? I mean lateral ties. See, this is connected here, this is connected here, and one more it is connected here. So this is how the connection is done. And these are the hooks, that is the links, right? We call it as links. So this is how it is bent. You have to bend it at 180 degree. This is connected from this particular rebar to the other rebar, right? Now, yeah, this is one more what we saw, the triangular one. If you can remember, the one is a master ring. I mean the outer ring which is connected. Then you have this, look at this. This is like a quadrilateral. It's connected from this column, this rebar to this rebar. From here it has moved here, and from here it has moved here. From here it has moved here. So it looks like this. Yeah. So this is how it is. This is a one. This is a one. One. Yeah. There are 2, 3, 4, 5, and yeah, this is 6. And there is one more here, right? 7, and this is 8 bar. This is a master ring which is connected, that you can see the outer ring. Along with that, there was one more bar which one more lateral ties which is connected like this, right? So this is the one more what you can see here. This is that one, this is that one, right? And this is hook. This is how it is connected, right? So these are the different ways of giving the lateral ties. Again, so far what we discussed is only for the square or a rectangular column. Sometimes from the aesthetic point of view, we give these circular columns. So this is how it's going to look. If you're giving circular column, these are the circular column, and these are the what you call lateral ties, or you can call this as spiral, right? So this is how it looks. Yeah, this is lateral ties. We can call this as circular ties. You can call this as spirals. So if you're providing a square column, in that case, this is how your lateral ties look. So now what is the idea behind giving various kinds of lateral ties, right? So far we have seen that, and we have tried to understand. But what is the main reason? Like sometimes we provide, this kind of, like sometimes what happens is we provide like this. Sometimes we are going to provide lateral ties like this. Sometimes we are going to provide only a hook, right? What is the reason behind all these things? We'll try to see that. For that, we need to refer SP34. This is a code book. Not a, yeah, this is from reinforcement, how you have to do the detailing. This is called as SP34. From there, it's mentioned if you want to a single tie can be provided when you have only 1, 2, 3, and 4 bar. In that case, you can provide only a single lateral tie. Just in case you have 6 rebar, I mean 6 longitudinal bar, 1, 2, 3, 4, 5, and 6. And in between this, the spacing is less than 75 mm. In between this, the spacing is less than 75 mm. In that case also, you can provide only one lateral ties. Even though there is 6 rebar, you can provide only one lateral tie if the spacing between this bar and this bar is less than 75 mm. Suppose if the spacing between them is greater than 75 mm, then we are going to provide two ties. One is this tie. One has this is from here to here. This is connected here, and the other one is connected from here to here. These things also we have seen practically. Suppose let us say the distance between these two rebar, I mean these two longitudinal bar is greater than 75, and from this outer bar to this outer bar, if it is less than 48 times the diameter of the lateral test. Let us say you have provided 8 bar, huh? And let us say yeah, 48 into 8 comes out to be 5 8s of 40, 400. So it comes out to be 400 84 400 484, and let us say this dimension is 500. So this 500 and this is less than 500. So in that case, what we need to provide in the center region, we need to give a link, something like this. We have to give a link like this. So I'll try to erase that again. Yeah, right. So this is how it is. So this code book mentions you how we are going to do the lateral ties. So based on the distance between these two rebar and these dimensions and all, this is how we are going to provide. Now let us say you have 1 2 3 4 5 6 longitudinal bar on this side and 6 on this side, and the spacing between these two is less than 48 times the diameter of lateral bar, and the distance between this is greater than 75. In that case, you have to provide one outer ring, then you have to connect then you have to connect this bar this way, and you have to connect this bar in this way. So this is how we are going to provide. So now to a minute before, what we saw is this kind of lateral ties, right? If the spacing between these two is greater than 75, and from here to here it is greater than 75, in that case you need to provide one lateral ties which goes full, and second one is provided something like this. We'll go back to that again. Yeah, this is what we had provided. So let us say the distance between these two is less than 75, and from here to here it is less than 75. In that case, we can provide like this. One goes the full, the second is connected in this way. So that is the same thing what is mentioned here. So this is what is mentioning. So these are the different ways of giving the lateral ties. Based on this, we are going to give the lateral ties. So this is another way of giving. So based on this, it is given for shear wall and all. So this is how the lateral ties are given. Now one thing we have to understand. So this is the other one. In terms of pedestal, this was given, right? If you can remember, like now look at this diagram and look at the pedestal what we saw. So these were the pedestals what we saw, right? If you can relate this, right? Look at the shape of this. It's something like this, right? And yeah, we'll see some other. Look at this. The shape is something like this, and yeah, that's all. So we'll try to understand that. You have seen the shape, and based on that shape, we have the lateral test to be provided, right? It is something like this. So based on that, this lateral test will be provided. Fine. So one thing we need to understand, whenever we give longitudinal reinforcement to the column, always we are going to give the even number. Let us say 1, 2, 3, 4, 5, 6, 7, 8 numbers are on this side. Even on this side, we are going to provide 8 number. It's not that 8 number on this side and 7 number on this side. That cannot happen. We have to equally distribute it. If it is 8 number here, then we have to give 8 number here. You can see any of the diagram. You look at here. There are 1, 2, 3 on this side. So there is 1, 1, 2, 3 on this side. Similarly, there is 1, 2, 3, 4, 5 on this side. So there is 1, 2, 3, 4, 5. So this is how we need to do the detailing of a column. Look at this side. On this side, 1, 2, 3, 4 is there. That is why you have 1, 2, 3, 4 here. Again, you have 1, 2, 3 here. That is the reason we have 1, 2, 3 bar here. So always you have to equally distribute the column reinforcement. Even though there is no need, like let us say you have done the design and all, even though there is no need to provide, but in order to satisfy this requirement, we have to give equal bars on both the side. If it is 4 bar on this side, then again 4 bar here. If it is 3 here, then again you have to provide 3 here. So this is how a column longitudinal reinforcement is to be given. And look at this. These are the 3 types what they have given. One is they are given the yeah, even we saw this, right? Right. So one you are given the entire bar. This is called as a master ring, and from here I have connected in a triangular way. From here I have connected triangular way. That is what we saw here, right? So this is how it is, right? So one is they have given full, then they have connected it like this, then they have connected it like this. So it again depends how we are going to arrange this longitudinal bar. Based on that, we are going to give this lateral ties. Yeah, I hope this is understood. We'll see you back in the next video. Thank you.